Let's switch gears and go back to limits. I feel like limits feels so far away. I don't know about you guys, but that just feels like a whole other time. But you will see limits on your test, so why don't we revisit them? So let's do one of these infinite limits. Um, let's do A, because A looks easier. So what you're going to want to do here is if you see an infinite limit, what you need to do is you need to identify the highest power, the highest term, the term that is going to grow the quickest, okay? So you have 1x, x squared, another x squared, and 7. Looks like to me x squared is going to be our highest term. So once you've identified that, you're going to divide every single term by x squared, or sorry, by the term that is the highest, which we have decided is x squared. Now, don't be weird with your simplification, okay? I think I graded this question this time around, and I saw a couple things. Okay, I saw some things. Remember, if you're dividing something by itself, for example, x squared over x squared, that is not equal to 0. Okay, it's equal to 1. So just don't be weird. So, wait. I said don't be weird, and then I was the weird one. Okay. So let's rewrite this as 1 over x squared minus x divided by x squared is, I'll give you a second to think about it. Yes, 1 over x, good job. Minus 1. 2x squared over x squared is equal to what? Well, this is equal to 1. So what's 2 times 1? 2. And then you have 7x squared. Okay. Now we're going to use our summation law, or difference law, and we're going to apply the limit. Actually, no. We're going to use our quotient law first, and then we're going to use our difference law. So what that means is we can just do the limit of the top divided by limit of the bottom because we've divided by the highest term. Okay? That's literally the only reason why we can do this. So, because it says justify each step. Okay, that was the quotient law, if you were wondering. Hence, I have a quotient. And then I can do the difference law, where I apply the limit to, that's not an x, apply the limit to each individual term. Did we need a name for this? No. Were you already going to do this? Yes. So Meg, what is the point? Guys, I don't know, all right? Just answer the question and follow the directions. I don't know. Okay. Meg, do I have to write all of this? Just do it. Just do it. Okay. Now we're ready to take all of these individual limits. 1 over x squared. As x squared gets really, really big, I'm going to have 1 over a really, really, really big number. Now, I'll give you a second to open the calculator on your phone and do 1 divided by the largest number you can think of. Like, start typing in a bunch of numbers. Okay. Ooh, that's a really, really small number. So where is this going? 0. So this is going to go to 0. This is going to go to 0. Guess what else is going to go to 0? Crazy. So I have 0 minus 0. The limit of a constant is a constant because think about it. If you have a graph and you have y equals 1, that looks like this. This is y equals 1. So as x gets bigger and bigger, well, what's happening to y? It's always going to be 1. Same thing with 2. Just know that the limit of a constant is the constant itself. Okay. All right. Mind your negative signs, people. This is going to give us -1/2. Okay?